We're going to continue our conversation about hurricanes, their impact, and what's coming next. And to do that, we've invited Professor Kevin Reed from Stony Brook University, a graduate of the University of Michigan. Kevin, tell us a little bit about what you're up to.
Yeah, great. So here at the Stony Brook University, I'm in charge of the Climate Extremes Modeling Group, in which we try to understand in general how a lot of different types of extreme weather changes with climate change. One of our particular focuses is tropical cyclones. And so we use a variety of tools, including global climate models that are typically used to project climate change, to understand how extreme events and tropical cyclones and hurricanes change with climate change.
So the common knowledge is that the oceans are warming, and therefore more of the ocean is going to be at a temperature which is at the right, well, it's the right temperature for hurricanes to form, somewhere above 80 degrees Fahrenheit. So do you expect then that there are going to be more hurricanes in the future, or more intense hurricanes in the future, or what is your take on this?
So that's a great question. Unfortunately, it's not as simple as the oceans warm, we get more or more intense storms. There's a lot of other factors that go into tropical cyclone formation and development. But the general consensus that a lot of work has shown is that in the future, storms are definitely likely to be more intense, that there's likely to be more precipitation associated with individual storm events. However, the actual frequency of overall hurricanes globally, as well as regionally in places like the North Atlantic, might actually be decreasing with frequency in the future.
And why would you expect a decrease in frequency?
So that's still a little bit unclear, and it's an area of active ongoing research. But there's a couple ideas in the sense that other environmental conditions, such as wind shear, which is basically the difference between low-level and high-level winds in the atmosphere, can act to inhibit tropical cyclone formation or development. And those type of changes are much more related to large-scale changes in the climate system, which we haven't actually been able to really knock down to specific areas yet, and where that shear might be increasing or decreasing. So if we have an increase in sea surface temperatures and in warmer oceans, which make tropical cyclones more likely, it's possible that we might also see an increase in shear, which might inhibit the frequency or development of tropical cyclones. But when a tropical cyclone is able to form, it definitely can become more intense.
Wind shear is also a function of what's happening in the Pacific, as I understand it, the El Nino, La Nina conditions. Does that come into play here as well?
Yeah. Yes, so it definitely depends upon the ocean basin that we're talking about. So if we're focusing on the North Atlantic, processes and oscillations and large-scale phenomena that do occur in the Pacific Ocean can impact natural variability of tropical cyclones in the North Atlantic, for example. And so there are seasons in which tropical cyclones, there's a lot of them in the North Atlantic, and there's seasons in which there's less. And a lot of that can be tied to things like El Nino, as well as other oscillations that occur at the global scale.
When we're thinking about changes in frequency or intensity of hurricanes, are there particular basins where you'd be expecting to see more impact than others?
So that is really an open research question. And that's an area in which we just now are starting to have the capability to actually do these type of research studies. And so I've been involved with some work recently in which we've actually been able to run regional projections of climate change, in particular ocean basins, and actually run, typical to what weather forecasters do, run a variety of ensemble models to try to understand if changes are robust across a variety of experimental conditions. And it's really hard to actually gauge regional changes of tropical cyclones yet. A lot of our initial work has shown that tropical cyclones in the North Atlantic, for example, will decrease in the future as a total frequency of all tropical storm strength storms. However, in trying to understand regionally where these decreases may occur, and whether those decreases actually lead to decreases in landfalling tropical cyclones, remains very unclear and uncertain due to potential large-scale changes. And actually how much the ocean surface is warm in the future is still actually unclear, and depends a lot upon potential policy changes that we make as a globe in reducing carbon emissions in the near future.
And what about the nature of tropical storms in the future? Like Irma is just ridiculously large compared to say Andrew years ago. So, do we see a change in the dimensions of these storms in time? Do we, in addition to their intensity?
So yeah, that's a great question. There has been some work that has shown that on average, it's expected that storms may increase in size in the future, but these differences that have been shown by a variety of modeling studies only actually maybe predict changes in size on the average size of a tropical cyclone on the order of a couple percent. And so the difference in a storm like Irma compared to something that happened back in the 1992 in Hurricane Andrew is much larger than that. And so that's likely due to just differences in the fact that some storms are larger than others. And while it's an active area of research, we're actually not necessarily always sure why some storms become so large and why some become so small.
All right, so we get hurt.
And I'd actually like to add one thing to that, is that in addition to size, while both Irma and Hurricane Andrew were both very intense storms, they both were very intense storms with different sizes. And so that's an important idea to make, is that, or assumption to make, is that strong storms are also very intense storms, and that's not always the case. And actually there is, in reality and observations, there's very little link between tropical cyclone size and tropical cyclone intensity.
Size doesn't matter. That's great. So one of the measures we make of hurricanes is the Saffir-Simpson scale, based largely on wind speed. But at least for a couple of recent hurricanes, including Harvey, the great damage came because it stagnated over land and caused tremendous amounts of flooding. So is that scale of hurricanes appropriate in this day and age?
So I think that there are limitations to the usage of actually the Saffir-Simpson scale based upon wind speeds as a determination for the potential destruction and the hurricane risk in the future. And so I'm actually involved in some work with some colleagues at other universities in which we've actually started to explore things that actually do control tropical cyclone size and intensity. And actually what we've started to realize is that things like looking at the minimum surface pressure and the difference of that minimum surface pressure from the background environment is actually more predictive of tropical cyclone size, because it's a quantity which actually takes into effect size and intensity. So if we think back not so distant past to Hurricane Sandy was a very large storm that was actually relatively weak, at least when it was making landfall in the United States. However, the central pressure of that storm was very low. And so the idea is that reproduced or indicated the amount of damage that Hurricane Sandy was actually able to do because it was so large. So just using intensity to understand the potential damage of hurricanes is not always the best technique. And so looking at things such as track duration, how long or how large a storm is and how slow or fast it's moving can really cause differences in damage. And in addition, things like storm surge also depend upon a lot of the geographic features. And so if you have a storm that's making landfall in an area that has a relatively shallow ocean, it's likely that the storm surge can be much more intense than a place in which the ocean is not nearly as shallow. And so it really often depends upon where the storm is making landfall as well.
So hurricanes are going to happen. That's a bumper sticker. Now, what sorts of policies can we look to that might help at least mitigate the damage that's caused, or help people afterwards to repair themselves?
Yeah, so that's the $1 trillion question, right? And so I think that the answer to this question is not straightforward, and it really depends upon where you are and in what role you're in. And so I think that preparing for future hurricane seasons, especially in the long run, really depends on coming up with local plans that are specific to your region. And so the impact of a hurricane in a place like where I live on Long Island would be very different than a potential of an impact storm in a place like Miami. And so first of all, the policy solutions, or at least ways to prepare, is really local dependent. And so part of this is trying to come up with better ways to understand risk in the future, and that potentially storm surge maps that we currently use to understand risk maybe need to be freshly updated based upon the fact that we know that things like sea level are rising, but also we know a lot more about storm surge than we did years ago. But in addition, this is coming up with plans, coming up with robust evacuation plans for your region, understanding that maybe storms are going to become more common later in the season or earlier in the season is something in which cities need to really start to plan for. But really coming up with policies in which you can make your city resilient to potential, not just hurricanes. Any storm, any city that is going to impact hurricanes is also going to impact or get impacted by other extreme events, such as just extreme rainfall, severe storms. And so you can build your cities in ways that are better prepared to what to do when you have excess water, particularly. This is particularly true in urban environments in which, in some regards, we've actually made our urban environments too efficient at getting water off streets and out of cities. And actually, if we build more green infrastructure in which we can really slowly percolate that water down into the groundwater in ways with green patches and having even a little bit of park or a little bit of grass on a street can really go a long way in protecting from flooding.
So in Houston, for example, you're proposing that if you were mayor of Houston and you could just redo it, would you then redesign it to be, when you say go green, that's I guess I want to know what that means.
Yeah, so it's used in two different terms, right? So one way of green infrastructure is just making your city and your buildings more eco-friendly, and so that's using really good, eco materials, cutting down on your waste products, and cutting down on your emissions. And so that's a great way to reduce the impact of our infrastructure on the environment as a whole. What I'm suggesting is that there's ways in urban environments to better combat extreme rainfall events. And so that's making, in some regards, your city more green by allowing more natural ways to facilitate getting water out of streets. Creating huge canals and gutter systems with sewer systems actually often produces bad outcomes, particularly if we use places like New York as example. When the sewage system fills up from rainwater, they often then release that sewage water into our natural waterways. And this is very common in a lot of cities. And so also building better technology so that doesn't happen will also help keep our natural areas clean.
All right. Well, I'd like to thank Kevin for all your answers. It's always good to talk to a graduate. And I hope that we can talk to you more in the future to hear how your research is going. Thank you very much.
Great. Thank you so much. And go blue.